South Korea built a bullet train network that goes nowhere beyond its own borders, and that's exactly why it's become one of the world's most advanced. In a country effectively cut off from any international rail links by the DMZ to the north, South Korea had to optimize high-speed rail purely for its domestic needs. The result is a hybrid bullet train system, one that started as a clone of the French TGV, but evolved into something uniquely Korean, combining European speed with Japanese-style precision. It's a system tailor-made for Korea's mountainous terrain and dense cities, with trains that accelerate like sports cars and glide through tunnels without making your ears pop. In a twist of engineering irony, the latest Korean bullet train isn't even the one with the highest top speed. Yet it might just travel faster in practice, thanks to what's under the hood. How did South Korea turn an imported train into an indigenous marvel? And what does that story say about the country's approach to technology and innovation? This is the story of the KTX, the Korean Train Express, and how South Korea perfected the high-speed train. Let's start with a quick snapshot of the playing field. South Korea's main high-speed rail artery runs diagonally across the country, from the capital Seoul in the northwest to the busy port of Busan in the southeast. This corridor is incredibly important. It's home to about 70% of the nation's population and handles roughly 2/3 of Korea's passenger and freight traffic. Before high-speed rail, a train journey along this 412-kilometer route could take 5 hours or more. Today, KTX trains make the trip in a little over 2 hours, slashing travel times by more than half. The KTX network now spans over 650 kilometers of dedicated high-speed lines, plus extensions on upgraded conventional tracks. It includes several lines branching toward other cities like Gwangju, Mokpo, and Gangneung. Seoul has multiple KTX terminals to send trains southward in different directions. At full tilt, KTX trains cruise at 300 kilometers per hour, about 186 miles per hour. On dedicated high-speed lines, they run on standard gauge, fully grade-separated tracks, meaning no road crossings, much of it through tunnels and over viaducts to handle Korea's tough terrain. In fact, roughly 1/3 of the original Seoul-Busan high-speed line runs in tunnels, and another third on bridges. That tells you just how mountainous and densely populated the peninsula is, requiring extensive engineering structures to achieve straight, flat alignments for high-speed travel. The trains themselves are impressive in scale. The original KTX train sets are about 400 meters long, that's 4 football fields, seating nearly 935 passengers each. They were built with technology from France's TGV and designed to hit 300 kilometers per hour regularly. Over the years, the fleet has grown and diversified, and Korea has steadily expanded and improved its high-speed services. The stage is set. Now let's rewind and see how it all began. Our story begins in the late 20th century. By the 1980s, South Korea was rapidly industrializing, and its main roads and railways were heaving with traffic. The government realized that the Seoul-Busan corridor, the nation's spine, desperately needed a faster way to move people and goods. Studies by French and Japanese experts suggested a high-speed railway could be the answer. Imagine cutting the 400-plus kilometer journey to under 2 hours, a revolution in connectivity. In 1992, Korea officially launched the high-speed rail project. But first, they had to choose a technology partner. There was a 3-way international competition. France's TGV, Germany's ICE, and Japan's Shinkansen builders all bid to supply Korea's new bullet train. After careful evaluation, the Koreans went with the French. In 1994, an alliance led by GEC Alstom, now Alstom, the maker of the TGV, won the contract. This choice was significant. It meant Korea's first high-speed trains would essentially be TGVs adapted for Korean service. The KTX-Eum, as the first generation came to be known, was based on the TGV Réseau model. Think of it as a French DNA train transplanted onto Korean soil. Each train had a power locomotive at each end and passenger coaches in between, a traction head design typical of European high-speed trains at the time. Alstom built the first few in France, then helped Hyundai Heavy Industries and Daewoo assemble the rest in Korea, transferring technology along the way. By the time KTX service launched in April 2004, Korea had 46 of these TGV-based train sets ready to roll. They were marvels of engineering for their day. 18 articulated passenger cars, plus the 2 power cars, all stretching 388 meters, and loaded with French tech like TVM 430 in-cab signaling. In trial runs, they could flirt with 330 km per hour, though in service they were capped at 300 km per hour. The KTX debut was a huge national event. Suddenly, a journey that took half a day by car or old train could be done in a couple of hours, city centre to city centre. Ridership in the early days started slower than forecasts, but it grew steadily as people adjusted to the new option. By 2010, daily KTX ridership was around 100,000 passengers and climbing. The new trains weren't just fast. They also brought comfort upgrades compared to older express trains and even to some overseas counterparts. In fact, although the KTX-Eum was based on the French TGV, passengers considered it more comfortable than its French cousin. The cars were pressurized against sudden tunnel air pressure changes, though not perfectly, as we'll see, and featured large reclining seats. First class even had swivel seats that could rotate to face the direction of travel, a classy touch borrowed from Japan's playbook, where rotating seats are common. Yet the early KTX experience wasn't flawless. With such a new system, there were inevitable growing pains. Some riders complained about pressure pops in their ears when the train blasted through tunnels. The seal on the KTX-Eum against air pressure changes wasn't sufficient for everyone. Korea is very mountainous, which means lots of tunnels, and when a bullet train enters a tunnel at 300 km per hour, it compresses the air like a piston. Without proper sealing and pressure control, boom. Passengers feel that uncomfortable ear-popping sensation. Engineers took note, and plans were made to improve pressurization in future train designs. Another issue: half the seats in any train face backward, and many Koreans found riding long stretches backwards made them dizzy or nauseous. The original KTX-Eum only had those rotating seats in first class, so economy riders were stuck facing whichever way their seat was fixed. This too would be addressed in later models by making all seats rotatable. Despite minor glitches, the KTX was a game-changer. South Korea had joined the exclusive club of high-speed rail nations, and it did so by absorbing foreign technology rapidly. But Korea wasn't content to just run imported French trains forever. From the start, there was an ambition to learn from the TGV technology and then develop something more domestic, more tailored to Korea's needs. This brings us to the next chapter in the story: how a team of Korean engineers got to work on an experimental train that would push the limits and set the stage for a new generation. Enter the HSR 350X. While the KTX-Eum was still being delivered, Korean research institutes and companies started collaborating on a project to build a homegrown high-speed train. This was often dubbed the G7 project, for seventh nation to develop HSR tech, and later known as HSR 350X. The goal: create a train that could reach 350 km per hour in tests, incorporating newer technologies and more Korean engineering expertise. In 2004, the HSR 350X prototype achieved a top speed of 352.4 km per hour, setting a new South Korean rail speed record. This was a big deal. It proved that local engineers could design and build a train capable of world-class performance. The HSR 350X looked similar to the KTX-Eum at a glance. It still had locomotive-style power cars at the front and rear, and was about 200 meters long per set. But under the hood, it had some upgrades: lighter aluminum car bodies, more advanced motors and electronics, and improved braking systems. It was essentially a testbed for features that would later go into Korea's next commercial model. After proving itself on the test track, this design was refined and slightly modified for mass production. The result was the KTX-2, later officially named KTX-Shinkansen, which entered service in 2010. The KTX-Shinkansen was Korea's first indigenously developed high-speed train to carry passengers. It still owed a lot to its TGV ancestry. For instance, it used 2 traction heads, power cars, and 8 articulated passenger coaches in between. But make no mistake, this was a Korean-built train, manufactured by Hyundai Rotem. It could cruise at 305 km per hour and featured a new nose shape to reduce drag and tunnel blast effects. Each set seated about 363 passengers in 2 classes, and multiple sets could be coupled for more capacity. The KTX-Shinkansen also quietly fixed some of the earlier comfort issues. All seats in both classes could now swivel to face forward, and the pressure sealing was improved over the original KTX-1 to better protect ears in tunnels. Passengers appreciated the tweaks. Ride comfort was enhanced with better seats and a smoother ride, thanks to refinements in suspension and track conditions. By building the KTX-Eum, South Korea had demonstrated something important: the ability to absorb foreign technology and then innovate on top of it. The country's model of technology development often follows this pattern: import, learn, improve, and export, whether in automobiles, electronics, or in this case, trains. By 2010, Korea had cut the cord from relying completely on foreign-made train sets. But an even bigger evolution was on the horizon, one that would truly set Korean high-speed trains apart from their French origins. Here's where our story takes a turn. Up until 2010, Korea's high-speed trains followed the same basic template: power concentrated in locomotive units at the front and rear, pulling unpowered coaches. This is the classic TGV approach, very fast on open stretches, but with some limitations in certain situations. Around the world, though, high-speed rail was evolving. Japan's Shinkansen, from the beginning, used a different philosophy. Every car in the train had motors, making it an electric multiple unit, or EMU. By the 2010s, European manufacturers too were shifting toward distributed power designs for their newest trains, like Alstom's AGV and Siemens' Velaro. Korea was about to do the same, spurred by its own unique needs and the success of an experimental project. The catalyst for Korea's next leap was an experimental train called HEMU 430X, High-Speed Electric Multiple Unit, 430 km per hour experiment. In 2013, this sleek prototype, colored in black and white, set a new national speed record by hitting 421.4 km per hour. In doing so, South Korea became only the fourth country, after France, Japan, and China, to test a train above 420 km per hour on conventional rails. The HEMU 430X was a bold departure from past designs. It was a true EMU, with no heavy locomotives at the ends. Instead, its motors were spread throughout the train. This distributed power setup promised better acceleration and climbing ability, crucial for Korea's hilly terrain, and reduced weight per axle. Engineers found that by spreading out the traction, they could lighten the train and reduce the wear on tracks, which in turn lowers maintenance costs. The test results were convincing. Shortly after those trials, plans were made to translate the HEMU's technology into the next generation of passenger trains. The idea was to build high-speed EMUs for actual service, stepping away from the locomotive-hauled model entirely. This is a pivotal shift in design philosophy. It meant the new Korean bullet train would have more in common with the Japanese Shinkansen than with the French TGV it originally licensed. Was that an admission that they chose the wrong model back in the 90s? Not really. The TGV-style trains served Korea well for 2 decades. But Korea's network had grown and its operational needs had evolved. The next trains had to handle more complex routes, including some steep, winding sections on newly built lines to smaller cities. They also had to dart in and out of many tunnels without rattling passengers. A distributed power EMU was the right tool for the job now. Welcome to the era of the KTX-Eum, the star of Korea's high-speed fleet today. Introduced in early 2021, the KTX-Eum is Korea's first high-speed EMU train developed entirely with domestic technology. Even its name, Eum, meaning link or connection in Korean, signifies how it connects regions and people. It's a direct descendant of that HEMU 430X test train. In fact, much of the technology on the KTX-Eum was inherited from the HEMU project, but packaged into a train optimized for real-world service instead of raw speed tests. So what's different about the KTX-Eum? For starters, it doesn't have big locomotives at either end. Unlike previous KTX generations that used traction heads pulling the train, the Eum uses distributed traction, motors spread across the train's cars. A typical KTX-Eum train set consists of 6 cars, with the end cars carrying driver cabs, but also seating, and 4 powered intermediate cars full of motors and passengers. In other words, every car contributes to propulsion. This arrangement yields several advantages: high acceleration and braking. Because multiple cars are powered, the KTX-Eum can accelerate faster and brake harder with regenerative braking. It can go from 0 to 260 kilometers per hour in about 12 kilometers of track, and it reaches its cruising speed quicker than the older trains did. For a country like Korea, where distances between stops can be relatively short and routes have curves, this high acceleration is gold. It means even if your top speed is a bit lower, you can average higher speeds over a given distance. By the way, the KTX-Eum service top speed is 260 kilometers per hour, a notch below the 300 plus of the earlier KTX-1 and 2. But thanks to its quick get up and go, it can often maintain schedules just as tight on certain lines. Lighter and gentler on tracks. Without two massive locomotive units weighing it down, the KTX-Eum has a lower axle load spread more evenly along the train. Hyundai Rotem, the manufacturer, claims this lighter profile extends the lifespan of rails and reduces maintenance, since no single point is grinding heavily on the tracks. Essentially, it's kinder to the infrastructure, a bit like the difference between a heavy truck and a series of lightweight cars driving over a road. Redundancy and reliability. In a locomotive-hauled train, if one of the two power cars fails, your train is in trouble. In a distributed power EMU, you have many motors. If one or two motors fail, the others can usually compensate and keep the train moving, perhaps at reduced speed, but it can limp to the next station. This was highlighted by Korail, the operator, as a safety plus. The KTX-Eum can operate even when one of the cars malfunctions, because locomotion is distributed. Passengers immediately notice some differences as well. The KTX-Eum's interior was designed with a lot of feedback in mind. For one, every row of seats aligns perfectly with a window. No more unlucky middle seats stuck at a wall. Seats are more spacious, with extra legroom and wider armrests, addressing earlier complaints. And yes, all the seats still swivel, so they can be turned to face the direction of travel at the train's turnaround, meaning virtually everyone can ride facing forward if they prefer. Tech amenities also got a boost. Each seat in KTX-Eum has a built-in wireless charging pad and USB port, which is a rarity on trains anywhere. It essentially treats your personal devices like an airplane would. You have in-seat power and even an entertainment display in some cases, making the ride feel more like a flight. Luggage racks are provided in each coach. No need to stow large bags at ends of cars like on older KTX. All of this contributes to a more comfortable, user-friendly experience for riders. Crucially, the KTX-Eum and its peers also benefit from lessons learned about tunnel aerodynamics. The latest trains have much better pressure sealing. As a KTX-Eum approaches a tunnel, the ventilation system automatically closes flaps to seal the cabin, mitigating that sudden air pressure change. The train's noses are sleekly contoured to reduce the shock wave as well. The result? You no longer get that painful ear-popping sensation every time you barrel into a mountain. This tunnel optimization was absolutely necessary given Korea's geography. With so many tunnels, you want a train that treats them as non-events for passengers. The first route to be served by KTX-Eum was the Jungang line, connecting Seoul, Cheongnyangni Station, to the interior city of Andong. This line isn't a straight-shot bullet highway like the main Seoul-Busan route. It's a winding mountain line upgraded for high speeds in sections, with a mix of new tunnels and older curvy stretches. Here, the KTX-Eum's strengths shine. It accelerates quickly out of stops, and its 260 km per hour top speed is plenty for the relatively shorter sprints between stations. It slashed the travel time from Seoul to Andong from nearly 4 hours to just about 2 hours, making weekend trips and tourism in these regions far more feasible. Ridership responded immediately. Within the first year or so, nearly 1.8 million passengers rode the new service. The train was so successful that more KTX-Eum sets have been ordered and deployed on other routes, like the line to the east coast city of Gangneung, replacing older KTX-Sancheon trains there. In many ways, South Korea's high-speed rail evolution with the KTX-Eum represents a hybrid of philosophies. They took the best of the French approach, high-speed rail know-how, signaling systems, proven aerodynamics for high speed on open terrain, and later blended it with the Japanese approach, EMU configuration for agility and reliability on challenging terrain. The result is a hybrid bullet train system that's neither purely TGV nor purely Shinkansen, but a blend, a French engine with a Japanese soul, one might poetically say. And it's working brilliantly for Korea. Let's zoom out for a moment and consider how this compares globally. South Korea, despite its relatively small size and unique situation, now operates a high-speed rail network and train technology on par with the best in the world. In fact, in some aspects, Korea leapfrogged ahead. For example, the United States, a far larger country, still doesn't have a true bullet train, as of 2025, whereas Korea has multiple generations of them. Europe's latest high-speed trains, like France's TGV-Eum or Italy's ETR 1000, have moved to distributed traction too, catching up to what Japan and now Korea have long recognized. If you want quick acceleration and efficiency, EMUs are the way to go. Historically, Europe favored concentrated power, locomotives, while Japan always used distributed power in its Shinkansen trains. China, which was a later entrant to high-speed rail, effectively imported knowledge from both and from the start built a vast network of distributed power EMU trains. Korea's journey is interesting because it started firmly in the European camp with TGV tech and then pivoted. The performance payoff from that pivot is clear in Korea's context. On a short, curvy network, acceleration beats outright top speed. A train that can hit 350 km per hour is great, but if your trip is only 300 kilometers with intermediate stops and lots of tunnels, you'll never reach that top speed for more than a few minutes. It's better to have a train that's nimbler, reaching 250 to 300 kilometers per hour quickly, and handling hills and tunnels with ease. That's exactly what the KTX-Eum delivers. And if we compare travel times, the latest KTX services are extremely competitive. The fastest Seoul-Busan trains, using another advanced model, the KTX-Sancheon, or even newer KTX-Cheongryong, can do the trip in roughly 2 hours 15 minutes on the direct high-speed line. That's for a 417-kilometer distance, comparable to Tokyo to Hiroshima or Paris to Frankfurt. Korea achieves these timings despite having chosen a slightly lower maximum speed class for its newest trains, again emphasizing acceleration and efficiency. Then there's passenger comfort and experience, where Korea's hybrid approach also shines. The French TGV influence gave KTX a smooth ride at high speed and a proven safety record. Decades of TGV operation with no fatal accidents due to technology. The Japanese influence, whether direct or indirect, showed up in attention to detail, like those rotating seats, meticulous scheduling, and dealing with mountain geography, tunnel pressure management, for instance. Today's KTX trains are airtight, air-conditioned, and quiet. Noise and vibration have been further reduced in the newest batches of KTX-Eum trains through refined bogie, wheel assembly, designs and sound insulation. This incremental innovation means that each generation of train is a bit more comfortable than the last. Surveys of KTX passengers have indicated that overall ride comfort is high, combining both the physical ease of the ride and the emotional satisfaction of speed and reliability. As one study noted, even though KTX was based on the TGV, Koreans ended up perceiving it as more comfortable than the original, likely due to these localized improvements.